Picture this. It's 1936, and a young British mathematician named Alan Turing is about to prove that some bugs in your code are impossible to find. Not with better tools, not with faster computers, but rather impossible by the laws of logic itself. Let's say you write a program that sorts a list. You run it, it does its thing, and then it stops. We say that it halts. But if you write a while true loop, then your program will run forever, never halting. So here's an interesting question. Could we build a halt detector that looks at any program and tells us whether it'll stop or run forever? This would be incredibly useful, since we would be able to catch every infinite loop before we even run it. On the first attempt, you just run the program and wait. But if it runs forever, well, you're stuck waiting forever too. That's not very helpful. On the second attempt, you try to set a timer. Give it an hour, and if the program finishes within an hour, you say it halts. But if it's still running after an hour, then it must loop forever. But what if the program takes 61 minutes, or a week? Slow is not the same as infinite, and there's no timer that can tell the difference. On the third attempt, you forget about running it entirely. You just try to read the source code instead, and trace the logic flow. For simple programs, this is pretty simple, but for anything with a lot of complexity, this isn't very reliable. Turing showed us it's not just hard, it's provably impossible. And here's how. Let's assume for a minute that our halt detector exists and works perfectly. Now you write a program called the troublemaker. It asks the detector, "Do I halt when you run me on myself?" and then does the opposite of whatever the detector says. Well, what would happen when you run the troublemaker on itself? If the detector says you halt, the troublemaker loops forever. That's a contradiction. But if the detector says you loop forever, the troublemaker halts immediately, which is again another contradiction. Both answers lead to a paradox. The detector can't be right either way, which means that it cannot exist. Now here's something you might find interesting. Although the halting problem was mainly presented for loops and recursion here, it is actually hiding inside everyday questions. When you ask, "Will this function ever return true?" that's actually the halting problem. And if you ever wondered, will your program reach a specific line of code? Again, that's the same thing in disguise. In conclusion, no linter will ever catch every bug. No model will ever verify your code is perfect. So programming will always require intuition. Testing will always matter, and debugging will always be part art.